Hello, and welcome to Component Rescue Board Repair. My name is Harrison, and today we'll be working on an 820 4924 board that is liquid damaged and has no power. So, let's go ahead and get started. So, let's switch over to there. Can't see much here, but as you can see, there is definitely liquid damage on the board. There's some more. We got some over here. So yeah, this board definitely a little gross. So let's plug it in and see what we get. So we do get a light on the charger, as you can see there. However, we get no fan spin, which means that the computer is not turning on. So, let's check out a few of these places that do have liquid damage on the computer. So we'll switch over to the board view. So one of those places is going to be right here, which this, of course, is going to be, what is this? This looks like a SPI reprogramming connector, which of course we don't really need on this. So I may just go ahead and pull it off, since as you can see here, it does have quite a bit of liquid damage on it. So let's see what those pins are. So we got some pins for the SMC, PP3V42, but yeah, we definitely don't want that. That definitely needs to go. So I'll get our hot air on. I'll add a little bit of flux to that so we can get it pulled off nice and easy. There we go. We got that off of there. So now I'll go in and I'll get it cleaned up, since that looks pretty nasty. Yeah, I did add a little bit of flux to there. So is my iron not heated up yet? Oh, it's not, so we'll wait just a moment. You know what, while we're waiting, let's see what this chip is right here. This chip, so this chip right here has a little bit of liquid damage on it, but I think it should still be fine. But we'll go ahead and remove this JTAG connector or whatever this is right here, and then we'll check and see if it turns on. So I'll go ahead and add a tiny bit more flux. And my iron should be nice and heated up by now. Looks like it is. Okay, there we go. And now we'll grab the wick, and we'll wick all of that off. Oh, come on. This does not want to come off of here. That's okay though. I can make it all come off. Okay, so let's get the last little bit of this off of here. That way we have some nice clean pads. Oh, come on. Okay, there we go. That's all pretty cleaned off now. I'll clean it up a bit with a Q-tip and some alcohol. Yes, I realized I got a little bit of solder on that capacitor next to it, but you know what? That's okay. Okay, and that looks cleaned up now. Yes, I know the two little pads at the bottom are connected a little bit. Oh, wait a second. There's a little resistor that got knocked off a little bit. But it doesn't really matter though. I can just leave it like that. That resistor is only used for reprogramming, so we don't really need it. And since it's only stuck on that one little pad and not connected to anything else, I'll just leave it there since it's not going to affect the way this board is functioning. But I'll probably end up taking it off after I finish the board. But since for diagnostic purposes it won't change anything, I'll just leave it as it is. And I plug it in, we get a green light, and we still get no fan spin. So let's take a look at the other side of the board. At this other spot that I saw quite a bit of liquid that could keep the board from turning on. And that's going to be right here. So this little chip right here is the clock chip. So without this chip, the board for sure will not be able to turn on. And as you can see, there's quite a bit of ugly corrosion and looks like a little bit of burn right there. So we'll definitely want to replace this, as this does not look very good. But so I don't burn it, I'm going to try and pull back this plastic. I think for now I may just pull it off and then stick it back on later. And wow, there's a bunch of corrosion under this. Okay, there we go. So now there's our clock chip right there. Is this in focus for you guys? Yeah, it is. So of course we're going to have to replace that. That is not going to cut it. And let's see, I think I got a replacement board right here. Is this the right one? Yeah, this is the right one. Look at this beautiful replacement board with a hole drilled in the middle of it. And these are great. These Chinese boards are great. I love them. Best part is they're only like 20 bucks, so can't complain that much. Wait, does this board? This board does have a clock chip. Okay. So let's go ahead and get this bad chip pulled off. Since we definitely do not want that on our board. There we go. And now we need to clean that off before we place a new chip on there. So add a bit more flux, and we'll grab our iron, and we'll tin all of those pads so that we can remove the nasty lead-free solder on there. There we go. And now we'll grab our wick and we'll wick it all away. Trim this up a little bit. There we go. So there we go. It's wicked it pretty good. There's a little bit left on the center pad, but that's fine. That's not going to be too much of an issue. So now I'll add some flux. And I'll tin the pads with some fresh solder. Okay, there we go. I'll add a tiny bit more flux. And now I'll go ahead and pull my chip off of the donor board. How am I going to do this? I'll just move this off to the side for a second. And then I'll grab my chip off of here. Come on. There we go. I'll set my little chip down for just a moment. I'll throw this board off to the side so that then we can work with this one again. And honestly, real quick, I'm going to pull this off, the little DCM board off, just so that this will sit. Well, actually, that didn't help very much. But, that's okay. I thought that might help, but it didn't. So we'll grab our replacement chip. And we'll go ahead and get it soldered on. First, I kind of want to just get the chip on there. And then I'll go in a second time. And actually get it aligned like that. Now we want to press down to make sure that it's flat. There we go. Now it's soldered nicely on there. I'll add a little bit of flux to it, and we'll clean up the excess around the edges. And then hopefully this little MacBook Pro will turn on. Hopefully. At least that's the plan. Oh, you guys can't see that very well. There we go. There we go. See that solder sticking out around the edge? That's what we're going to clean off. There we go. So now we got our brand new clock chip soldered on there. Or brand new. So now I'll go ahead, flip the board back over, and I'll put my DCN board back on here. And we'll plug it in and see if we get it to power on. Let's see. And we still get no power. So now why exactly are we getting no power? It could be for quite a few reasons. So let's see, where else was there liquid damage besides there? Actually, I'll go ahead and touch that up just to make sure that maybe it's not fully pressed down. Ooh, so it looks like maybe that wasn't pressed down all the way. I'll clean that up a little more and then we'll try it out again. You know, sometimes I'm just very bad at soldering these and I may have to do it once or twice before I get it right. But you know what, that's okay, because as long as it works in the end, everything's great. Okay. Now let's try this again. So hopefully I can plug this in and we'll get it to power on. Have the light. Well, so what else could possibly be causing this not to power on? There could be many things causing this not to power on. So I may look around the board a little bit, and if I can't find anything else that's obviously not causing it to power on, we can start going through our power rails. So this right here, this is going to be, I believe, where PP bus G3 hot goes into the computer. That definitely does not look very good right there. Let's get a little bit of that corrosion off of there. This should still be fine though. So there was that. I'll flip this over. There was also some corrosion down here. That shouldn't be causing the computer not to turn on. This one looks like it's going to be a tricky one. So something else I did notice too is over here on the SMC that there is a bit of corrosion there. So that could very well be what's causing this not to come on. Which a good cleaning could very well get this computer to turn on. Now the most straightforward way to get this working again would probably be to reflow or replace the SMC. However, both of those are fairly difficult to do, and I really don't feel like doing either of those. So I would much rather run this computer through the ultrasonic cleaner first before trying to replace the SMC. If you really want to see what goes into replacing an SMC, I think I do have this older video where I actually replaced one to get the computer working again, and it is just not that fun. But if I have to do it, I will. So another place we got some corrosion though is going to be over here in this area, which, let me check the board view to see what we're looking at. So this is going to be for Thunderbolt over here, but I mean that looks pretty nasty. So I'm thinking I'm going to have to go through the power rails on the computer. So here we go. Time to find the power rails. Let's just search power. Wait, I think there's just one L. A-L-I-A-S. Next, here we go. So I'll zoom in a little bit. So I guess we'll just start at the beginning and see what we have. Obviously, since we have a light on the charger, I know we have PP3V42. So I'll just go from there and we'll see what we're missing. So the first one is going to be PP bus G3 hot. And of course, as always, I'll measure these and then read out to you what their value is. So PP bus G3 hot is 12.56 volts. So that's going to be great. So a lot of these I can skip over for now. PP3V42, we know we have that. PPVRTC. Let's see, where can we find that? PPVRTC. This is one of the ones required for the computer to turn on. Where's a good place to measure this? There isn't really a great place, but we can do it by the clock circuit. That looks like the best place to me. So we'll do a quick little measure right there. And 3.3 volts, so that's fine. So I'm just going to go ahead and check, just to skip through quite a few of these. I'm just going to go ahead and see if we're making it to an S4 state, just to make my life a little easier. PP3v3 S4. We can measure this right there. So, something you can do, once you have a bit more experience, is you can kind of skip some of these by just jumping ahead. Usually when you're first learning how to do this, it's pretty helpful to go ahead and measure everything. But a lot of the times, you can kind of skip ahead. Oh, I'm on the wrong side. I'll just measure it over here. So we'll just take a little measurement, I guess, right there. And we'll see what we get. So for PP3v3 S4, I'm actually getting 3.3 volts. Which is good. That means we're making it to an S4 state. Which means we're probably also making it to an S3 state. So let's see if we're making it to an SO state. If we're not, I can always go back and check the S3. So we can find that right over here. Where is that? That's by an inductor. So 3.3 volts. So that's good. That means we're making it to an SO state. In fact, now the CPU's actually heating up, which means maybe this computer is actually turning on and it just doesn't want the fan to spin on it. So let's see. So if I were to grab a mouse and plug it in, do we get power on there? Because maybe the computer is turning on now and it just doesn't want to act like it is. So let's see. What do we get with this little USB mouse? Well, the mouse seems to be acting like the computer's powered on. Maybe we are powering on. Maybe there's a sensor issue that's keeping the fan from coming on. Honestly, those pins over there none of those pins look too great. This whole section kind of looks like trash. Let me switch back over to it. There we go. This for the LCD all kind of looks like trash, but all the pins still look fine for the most part. There is a bit of rust under this right here, which I believe is what tells the panel to turn on. And then on the other side, we have some crap on the Thunderbolt controller. I may just go ahead and stick this back in the computer and see if we get an image on the screen. Because if we do, or if we at least get a backlight, I know that this computer more than likely should be good to go. So let's just set this in here. Doesn't have to be fancy or anything. So I'll get that set right there. I'll open the lid up a little bit and I'll plug it in and let's see what we get. Do we get a computer that boots up? I sure hope so. Oh man, I'm not seeing anything on the screen. We are getting CPU V-core because the CPU is getting hot. I could always check the V-core to make sure that the V-core is correct. We may be getting a low CPU V-core, which could be keeping it from turning on. So let's see. This area over here had a bit of corrosion near the CPU, but that should all be fine. There's a bit more corrosion. Actually, we may have some corrosion underneath the CPU, which could be keeping this from turning on since I'm seeing corrosion from right around it. So I may have to run this one through the ultrasonic cleaner before we can see if it works or not. So I may go ahead and just do that now. So let's see, where's the T5? Let's get it turned on. Oh no, where'd my T5 go? Oh, here it is. So I'm gonna go ahead and pull the heatsink and fan off so that I can get this ultrasonic, since I have a reason to believe that there's corrosion under the SMC and CPU that could be keeping this from turning on. So you can't really see it. You can't see it here, but I do have a little ultrasonic cleaner over here. If I turn it on, I'm sure you can hear that. It's pretty loud. But I'll go ahead and let that heat up. It usually takes like 30 minutes. Then I'll run it through there, clean it off in some alcohol bath, and then I'll let it dry for a little bit. And once it's dry, I'll probably pull the stream back up and keep going from there. And hopefully I can solve it then. But I would keep going on this, but since I'm pretty sure there's going to be corrosion under the CPU, it's just not worthwhile to keep going on this. So there, we got that off. As you can see right there, the liquid damage goes underneath the CPU, which is not a good sign. And we also have some over here that looks like it goes on the RAM, which is also not a good sign. And then of course there was some over here by where'd the SMC go? There's some on the SMC too. I don't see any broken traces though. So hopefully a bath will clean all of this off, and I guess I'll continue it from there. So hopefully I'll be back in a few hours and we can finish up on this board. Bye for now.